Hello everybody. This video is to help you convert from standard form of a quadratic to the vertex form of a quadratic. Now I want you to notice right off the bat, our a terms are going to be the same for both forms. There's multiple ways that we can convert from standard form to vertex form. I'm going to show you both. So let's start with the equation 2x squared plus 16x minus 5 equals 0. We already know that this is in standard form because we are equal to 0. Now, just like our solving by completing the square, we're going to start by moving our constant over to the other side. So we've got 2x squared plus 16x equals 5. I want you to notice that our a is not 1 here. So before we complete the square to turn this to vertex form, we're going to have to factor out our 2. So that's going to give us an 8x here, and we still have our 5 on the right-hand side. Now we complete the square. We're looking at our b being 8, so we're going to do b divided by 2 squared, or 8 divided by 2 squared, which is 4 squared, or 16. Now, since our a is not 1, we notice that that 2 is being distributed into our 16. So that means we're really adding 32 to both sides. Now from here, the reason we've made this perfect square trinomial is so that we can factor it, and we can write it in that vertex form with the square. So we've got 2x. What goes here is half of our b. Since our b is positive 8, when we divide positive 8 by 2, we're getting that plus 4. And now this equals, when I combine my like terms, 37. Now if you notice, we're really close to being in vertex form. To be in vertex form, we have to equal to 0, just like in our standard form. So to get this equal to 0, we're going to subtract 37 on both sides of our equation. So we've got 2 times our x plus 4 squared minus 37 is equal to 0. So we're now in vertex form. This is one way we can get to our vertex form from our standard form. The other way I'd like to show you is if we are looking for an a, an h, and a k. In our standard form, we can easily see our a, b, and c. The a will stay the same. So we already know in both forms our a is equal to 2. To solve for our h, we're using the equation for the axis of symmetry for this quadratic, or the opposite of b over 2a, which we can get our a and our b from our standard form. So our h here, the opposite of b, would be negative 16 over 2 times a, or 2 times 2, 4. So we now have h equals negative 4. So we've got our a equals 2, our h equals negative 4. To get our k, we are going to plug h into our equation, because this is basically an x value. This is the x value of our vertex. If we plug it back in, we will get the y value of our vertex. We're going to plug that into the standard form. Anywhere we see an x, we're going to put negative 4. So we've got 2 times negative 4 squared plus 16 times negative 4 minus 5 equals 0. And we're going to simplify this down to find out what we get. And this actually equals our y term. I apologize, because we're solving for y, or in this case, k. So order of operations tells us we're going to square first. We've really got 2 times 16. We can multiply here to get negative 64 minus 5 equals our y, or our k term. 2 times 16 gives us 32. When I combine like terms here, I've got minus 69. 32 minus 69 will give us negative 37. And again, our y is the same thing as our k term. So our k term is equal to negative 37. So we now have the three pieces we need to write our vertex form. Let's see if they match. So we've got our a is 2, x minus negative 4rh squared plus our negative 37. Okay, so let's simplify this down. We know when we subtract a negative, it's the same thing as adding. So we really have 2 times x plus 4 squared, and when we add a negative, it's the same thing as subtracting. So both ways will work to go from standard form to vertex. Good luck, guys.